Alright, so here's an annoying and slightly confusing question. It's about balancing a reaction, but it's specifically balancing a reaction in an acidic solution. So here we go. And the reason why it's annoying is because although a question might require you to balance the reaction, balancing the reaction requires several implicit steps that may not be explicitly stated in the question, okay? So here we go. So first, this is our acid, H plus, okay? Got that? And permanganate, MnO4 negative, okay? Plus Fe2 positive. All right, so this is going to be the left-hand side of the equation. And because I'm definitely running out of space, because I tried to make this look cute, I'm going to have to swing it around. So on the right-hand side, or the reaction side, we yield Mn2 plus, all right, plus Fe3 plus. I hope you're writing. Plus H2O. And the reason why we know that we're balancing in an acidic solution is because we have H plus. So I'll give you a moment to think about this because like I said before, there's several steps implicit here, okay? Alright, so the first thing that we're going to do is break up the reaction into half reactions, and I'm going to first start with manganese. So Mn, we have it here, so we have 1, okay? But we also have to consider the charge or the oxidation state. So manganese normally has an oxidation state or oxidation number of +7, and I don't know how to get you to figure this out other than you have to memorize something like this, okay? And then that's going to yield this cation on the right-hand side, Mn2 plus. All right, so how do we go from this to this? So basically, in order to get from an oxidation state, if you swung the positive sign around here, you can call it Mn7 plus. I don't know much cations with that number, but the way to balance it is to add electrons. So in order to go from +7 to 2 plus, you would have to add 5 electrons with a charge each of -1, okay? So there we have the manganese sorted out. Notice I'm dealing with all like my species that don't include H or O. I did that in reverse. The next thing that I'm going to sort out is every species that doesn't have like an H or an O. Because the HOs essentially yield water on the reaction side. So I'm not worrying about that right now. And don't ask me why, just know that this is a step that's implied, okay? So then you have to sort out Fe2 plus on the left-hand side. I think this is cuprous, and you're going to yield cupric, Fe3 plus on the left-hand side. And like I said before, in order to balance this, you have to basically add an electron. And we're always, you know, going from higher oxidation numbers or charges to lower oxidation numbers or charges, okay? So in order to get a positive 2 or a 2 plus charge, we would have to add 1 electron with a charge of -1, okay? So these are our two half reactions. And so the next step basically is to balance the electrons. We're not really worried about this for right now because we were able to extract our two half reactions. So in order to balance the electrons, I'm going to have to manipulate the second half reaction a little bit. So notice this is another implicit thing that you have to do when balancing these types of equations. You have to do some algebraic manipulation. In this case, we're going to multiply by 5 because if I have 5 electrons on the right-hand side over here, because eventually I'm going to put these two half reactions together to make a full reaction, I need to have 5 electrons over here because you know matter can neither be created or destroyed. You have whatever you have on the reactant side, you have to have on the product side, okay? So you can't have unbalanced matter or mass or whatever you want to call it. All right? And so now that we're doing this acidic environment, we see that we have basically, we start out with like a proton on this side, okay? Or actually, no. We have water as, no, actually, now we need to balance the oxygens. And the way you balance the oxygens is just by like adding water and stuff, okay? So if I have, if I have 4 oxygens on the reactant side, I need to also have 4 over here. And if now I end up with like 8 hydrogens, and all I would do basically is add like an 8 in front of the H plus in order to, you know, get a balanced equation with an equal number of hydrogens on this side and an equal number of hydrogens on that side. And so now that we've balanced the charges, we don't really need to write the actual electrons in the final equation solution, although we went through all this work. So basically you just kind of cross them out. But what will have occurred is we increased the number of cuprous, Fe2, and cupric ions. Okay, so you're going to have to indicate that increase by putting a 5 as the leading coefficient on the cuprous ion and a 5 on the cupric ion. And I'm pretty sure that like this is like the final balance thing. Sorry that this is such a long explanation, okay?